This conference will now be recorded.
Hello, my name is Steve Higgins. I'm with Rolls Battery Engineering, and I am here with Patrick from Washington, from Solar Washington. We are doing a webinar. This is actually a re-record. Unfortunately, the webinar that we did on July 23rd, 2020 didn't record for some reason. So I am re-recording this now, so I can put this, so we can post this. This webinar's base is battery-based energy storage. That's the main topic. So we're going to talk a little about off-grid, grid tie with batteries, things like that. My contact information, my name is Steve Higgins. This is my contact information. Feel free to reach out to me if you have any questions. I'll be more than happy to answer those questions for you. So one of the most important things to remember about battery-based grid tie or about battery-based systems in general, is a lot of times when you start talking about solar systems in general, the number one question you get is, how much is this going to cost me and how much do I need? The number two question usually is what is the return on investment? You want to be really careful and cautious about the return on investment on systems, especially battery-based systems. When you start talking about about grid tie systems in general, you're trying to lower your electricity bill. Generally, people are trying to lower their electricity bill. I would say majority of people, probably 65, 75%, it's all about the cost. There's another 20, 25, 35% that are talking about environmental issues. We understand that. Most people, unfortunately, what they're trying to do is, if they've got if they're consuming 14, 16, 1700 kilowatt hours a month, if you're consuming that much power and you're paying 25 cents a kilowatt hour at 1500 kilowatt hours, your base electricity bill is close to $400 cost. By the time you put in taxes and all the other things, you're paying $400, $425, $450 a month in electricity bills. If you go in and you throw in a $50,000 system where you're saving $200 to $300 a month of electricity off your bill, that's where you get a return on investment, because typically you're looking at 20 cents a kilowatt, 25 cents a kilowatt hour. You're looking at ballpark, 3 to 6 years, depending on your electricity costs, for a return on investment. When you throw, 10, 20, 30, $40,000 worth of batteries into a system that you have to replace every, 6, 10, 15, 20 years, it's very difficult to price out that return on investment, because it's not really an economic choice. It's especially battery-based off-grid systems, you have to have power. In a lot of places, you can't even get a loan on a house that's off-grid if you don't have certain amenities like power, running water, things like that. A lot of places, up until the mid or the early 2000s, you couldn't even get a loan. There were only a few banks that would finance homes like that. So you don't approach a battery-based system like you would a grid tie solar system. Battery-based systems are generally installed for two reasons. One, the number one reason, most of the stuff that I see out there, is the home is not on the power grid, which means you've built the house in the middle of the desert, middle of the woods, in the middle of Montana, and you didn't want to pay the fees to get the lines out there. The next reason is the utility is unreliable. Over the last couple decades, we've seen utilities become more and more unreliable. And so people will put in a battery-based system to act as a backup. So off-grid systems, generally systems I've seen off-grid systems run as low as $10,000, $15,000 US. I've seen and personally have been involved with systems that run as much as $175,000, $200,000 US. I went out to a system in the Bahamas once where the customer was connected to the grid, and they wanted to take everything off grid because the grid utility didn't want them to stay connected to it anymore, because it was a pretty large 150 kilowatt array, and they were worried about stability issues. and the customer wanted to incorporate a bunch of batteries. And that would have been a $4 to $5 million installation because of the additional space they needed for battery rooms and the amount of load that the customer was running, and they were running air conditioning 365 days a year. So you can see some pretty expensive systems out there. For off-grid systems, getting power to remote locations can be cost prohibitive. When you're running a power pole cost, you're looking at $500 to $1,000 depending on the terrain, depending on the utility, depending on where you live, depending on the environmental. So I've seen quotes. I had a customer in the Mojave Desert who was 3 miles off the line. He actually had to run 4 to 5 miles of posts, and he was looking at $200,000, $300,000 just to install power, and then to follow that up by paying the public utility district a monthly bill on top of that, plus connection fees and all the other things. He decided to go completely off grid and put in battery bank systems. Couple of key points about off-grid systems. The system must be sized according to the customer's loads. If you are not sizing the battery bank according to the customer's loads and you're just ballparking it, you want to be careful with that because eventually it will come back and bite you. The systems must be balanced. What that means is that when you're dealing with battery-based systems, regardless of the chemistry, you need to balance it. So if you put in 1,000 amp hours of batteries, you need to have a certain amount, typically 10 to 20% of that in a single charging source, preferably the solar, the renewable charging source, because that's free energy. So you must maintain that balance as the system goes. So if you install the system and then 3 years down the road, the house sells to a new client, or that client adds a swimming pool or a jacuzzi, or they have a baby, that's going to throw the balance of the system off because loads are going to increase, and that increase in loads can cause problems with the operation of the system. Lastly, and the most importantly, is that customers must be educated how to operate the system. When you get that system done and it's commissioned and it's running, the best thing you can do is you walk the client through how to operate the system. What's the main disconnect? How do you program settings? How do you get into the charging settings? How to do maintenance if maintenance is required, all those types of things and more. And so they must be educated, because the last thing you want to happen is you install a system and then you're starting to get calls or phone calls or emails about how the system doesn't work. That just gives you a black eye, and it gives you a black eye, and of course the manufacturers that you've installed, it gives them a black eye as well. On grid connected backup, typically in Washington, especially Western Washington, we see a lot of primary backup systems. You get into the foothills of the Cascades. Over in Eastern Washington, you see a lot of full full-time off-grid systems. Grid connected backup systems or provide backup power as a service interruption, or to provide a buffer for selling back power to utility for a battery-based inverter such as the Outback or the Schneider inverters. They need to have a battery to be able to sell back power to utility. And so again, these systems need to be sized properly, and so it's all about maintaining that balance. On a grid backup system, these systems are designed to be back up necessary loads during an outage. Like, for example, my home, I have about a 1,800, 2,000 square foot home. Got the wife, I've got 2 kids. There's a main panel, and then there's a breaker that goes from the main panel, that goes to the input of the inverters. The inverters go to the sub panel, what I call the critical load sub panel. And in that critical load sub panel, there's basically 3 circuits. There's the kitchen circuit, there's the living room circuit, and there's the master bedroom circuit. And those circuits are powered from that critical load panel. So if my utility power drops, the batteries engage, the inverters see that, and they start drawing power from the batteries, and then the batteries power the loads in those circuits. So it keeps the refrigerator cold, it keeps the TV on, and it keeps the circuits in the master bedroom on. So unfortunately, the kids' rooms don't get backup. They're just going to have to deal with it. Ideally, you size the necessary loads to the secondary sub panel. For lead acid batteries, 80% depth of discharge cycling, because it's going to be something that happens only, 2, 3, 4, 5 times a year. If it's a lithium ferrophosphate battery, typically you size for that 80 to 100% depth of discharge. So we'll get into a little more of that on the calculations. So battery sizing considerations, you've got to understand what type of system your customer wants. If they want a full grid tied system without batteries, that's the simplest. You size the system, you use the electricity bill, you size the system to sell back the percentage of power they want to sell. Once you flip the switch, you're basically done. There's hardly any maintenance other than checking connections periodically and cleaning of panels. Grid tied with batteries, basically you're doing a support mode or you're doing a grid backup mode. And so basically what you're doing there is you're using the batteries to support the loads, or you're using the batteries to support the loads during an outage. And then lastly, your off-grid systems, which are completely 100% off-grid, and those systems where you need the most balance, because if you don't, you're going to get 1 or 2 years of operation. If the customer throws in a bunch of extra load that shouldn't be there, you're going to get that 24 to 36 months worth of good operation, and the system's going to start to have problems. And again, that just gives everybody a black eye. To understand this, you have to sit down and interview the client to figure out what they need. If you don't do that, you're going to run into trouble. So how do you do that? Well, it's very important to know what kind of loads the customer runs, and that requires an energy audit. And it's okay to charge for an energy audit. To this day, I still charge for energy audits that I go do. The number one reason I do is I don't sell full systems anymore. But if you sell full systems and you're doing the installation, it's a good idea to charge for the energy audit. You drive out there, you go through, you put some meters on, you check where the surge loads are, you check what the actual loads are. You leave the meter for a few weeks or a few days to ensure how much load the client's actually pulling, and then you can figure out what size system they can get, what size system they need. The other thing that you can do is you can go out there and look at all the loads and make calculations. And, on the back of all of our appliances, it tells you how many watts or how many amps it runs. So if it runs at 5 amps and it's a 120 volt load, it pulls 600 watts. 600 watts for half an hour. That's, it's 300 watt hours. That's what it's going to run over a 24-hour period. So it's not that difficult to do it. It just takes time. One of the favorite questions I have, and I am a bit skeptical at times, and skeptical is not the right word, but one of the most annoying questions that we get is you get the phone call with the client who says, I have a 3-bedroom house, how much is this going to cost me? Or I have an 1,800 square foot house, how much is it going to cost me? Well, me being I'm a smart aleck, and that's the nice term for it, I like to ask them what color the house is. And the reason for that isn't to be a smart aleck. The reason for that is to kind of wake the customer up. Usually the customer that's going to buy the system will ask you, well, it's blue. What does that have to do with it? Or it's brown. What does that have to do with it? If the customer flat out tells you that the house is red, and doesn't clue into them, that's the type of customer that you're probably going to eventually have issues with, because they haven't done a lot of research and they're not a self-starter. So just be cautious with that. You can take 100 families and put them in the same house, and you can get 40 to 60 different load profiles, because it's all based upon the load. Standing in front of NABCEP last year, there was a NABCEP group last year. We were in, I can't remember where we were in. We were supposed to be in St. Louis this year. I think it was San Diego last year. Standing in front of a group, yes, the solar electricians who were doing solar installations. And you say, I always ask, how many electricians know how much power they consume? And usually I get 10, 15 electricians that raise their hand and know how much power. So more than half of them don't have any idea how much power they actually consume. So it's a good idea to if you're practicing on designing a system, practice on your own power consumption and see what size of a system you need and experiment with it. And if you got the funds, do your own installation. All right, so here's some of the questions you ask them. Like, what do they want on the power? Why do they need the power of the 10-ton air conditioner? Do they have a room to install a system? Are you going to have to build an outbuilding? Are you going to have to, take over some of the garage? I can't tell you how many outbuildings that I've put up in the desert just because the wife didn't want or the husband didn't want the batteries or the inverters in the garage. Have they completed an energy load evaluation? If not, get one done with them. If they don't want to do them, they don't want to pay for your time to do them, they're probably not going to buy the system. Is the client going to stay within size loads? If not, if they look like they're building their home and they haven't quite decided what their loads are going to be, it would be a good idea to upsize the system to cover your design factors. If they don't, it's always a good idea to make the customer sign off on the load evaluation form to make sure they understand if they pull more current, it's going to make the system smaller effectively. What are their full expectations? If there's problems, are they going to come after you or legally come after you? These systems aren't perfect, so that's definitely something to keep in mind. Is that these systems in general, they're not 100% perfect systems. There's going to be problems, and is the customer going to be able to solve those problems? Is the client going to properly maintain a battery bank or the system in general? If they're not, sell them a service contract. Can they afford to live off grid? Living off grid's not cheap. I did it for a few years. There's always all kinds of little stuff that you have to buy and use and deal with. If they're scrimping and saving every single penny, an off-grid system might not be what they need. It may be more cost prohibitive for them. So it's something to look at. So here's a load profile. Typical load profile of a home. You get people that people wake up in the morning. They start. The coffee pots are running. Breakfast is being cooked. All that stuff. You've got loads in the morning, and so in the mid morning, late morning, early afternoon, everybody's going to work. Everybody's going to school. There's nobody home. There's probably fans and light loads going on in the house. No big deal. The big loads typically are when customers come home. That's when dinner and chores, laundry gets done, vacuuming, cleaning gets done, things like that to get taken care of. That's when the bigger loads present themselves to the systems. And so it's important to understand the load profile. This is what the sun profile looks like. And so typically solar comes up, solar peaks up, and you get a nice little like inverted, like a bell curve, inverted bell curve. And so this is typically your typical sun profile. For a full-time off-grid system, your peak consumption is going to be roughly between 10 a.m. and 2:30 to 2:30 p.m. Okay, especially for a fixed array. If you got a tracker array, it's going to look more like it's going to look more like this. But if it's a fixed array, it's going to be basically the same or close to the same every day. If you overlay those two over the top of each other, this is what you get for a load profile versus a sun profile. So what ends up happening is that all this load needs to be powered, and you need to charge the battery with this amount of sun. And so that's where the solar needs to be properly designed to. If you don't, what's going to end up happening is your customer is going to be running a generator a lot. My opinion, twice a month's too much. Especially during the peak season. My opinion, most systems, you really want to run the generator only in the winter months. In the summer months, you typically don't want to run the generator, but once a month, maybe to exercise it if you have to. This is what the consumption looks at my house, especially when I'm home, especially in these days of COVID where I'm stuck home and not traveling. I've had about 10, 15 trips canceled this spring and summer. But this is what it looks like in my house. If I put that array in that system, my batteries are going to be in a discharging state as we go along because I'm not offsetting it with enough solar to keep those batteries charged. Some other things to consider. Again, time of use. When is the customer using power? Are they using power while there's sun? If they're using power while there's sun, you may have to upsize the array. If you're installing a system in Eastern Washington that's fully off-grid and they're running air conditioners from 10 a.m. to 4 p.m. or 10 a.m. to 8 p.m., you may need to upsize the size of the solar to offset that air conditioning use, okay? And so you need to take into account what's running during the day. Type of use, is the client a full-time off-grid or are they a backup or a cottage use? Full-time off-grid, you typically size the battery bank from 50 to 75% DOD. If it's a backup system, you typically size from down all the way down to 80% depth of discharge. Cottage use, you don't have to have as big of an array because they may be running, they may be there for 3 days a month, every other weekend or something like that. So you need to take that in consideration while you're talking about systems. Lastly, are they going to take care of it? So if you're gonna put in a set of flooded lead acid batteries, are they going to top off the water? Are they going to maintain those batteries? You want to be cautious with that because if you go and you install it and then 2 years later somebody gets sick or they just stop maintaining it, it goes and it fails, and the next thing you know they're coming after you, or they're going after the battery manufacturer or the inverter manufacturer because they didn't take care of it. So sometimes if you have a client who's not going to take care of a battery bank, or you have that feeling in the back of your head that doesn't ensure that they're going to take care of that battery bank, especially if they're not asking questions, sometimes it's better just to move on and send that customer to your competition. I like to call them the Scud missiles. Send the difficult clients to that competition to try to prevent that. So here's an example of power consumption. And so you notice one of the things that I did here is I did break out the refrigeration and I broke out the heating. Miscellaneous electronics. This is, by the way, when I was living by myself with my son. Miscellaneous electronics is a little high, and that's because this was done in the early 2000s when there were a lot of electronics going. Water pumping. I was living in the desert, and so I had to run my pump 20 minutes a day to refill a cistern. If it's on-demand water pumping, this might be a little more depending on how often you're using water. Various kitchen appliances, coffee maker, microwave, stuff like that. Laundry, of course, lighting. Lighting here is huge. This was done in the early 2000s, from 2002 to 2005. The lighting was because I was using incandescent or compact fluorescent bulbs. This was not LED bulbs. So nowadays, LED bulbs, this number would be closer to the 0.5 kilowatt hour range, or even maybe a little bit more. So again, this is just an example of a general power consumption. Common system sizing mistakes. Number one mistake is oversizing the battery bank. And what that means is there's a lot of customers who have this go home or go big or go home mentality when it comes to sizing the size of the battery bank. A lot of guys think it's okay to put a 3,000 amp hour battery bank with a 1,000 watt solar array. That 1,000 watt solar array is never going to get that battery bank fully charged. It will take weeks and months, and that battery bank will sulfate and it will fail. The other problem is there's too many parallel strings. When you put in, like for example, if you're going to do a 2,000 amp hour battery bank, you either use a 1,000 amp cell or a 2,000 amp 2-volt cell. You do 24 in series. You have 24 cells to maintain. If you try to do that with L16 batteries, or even worse, group 31s, you're going to have 5 to 10 parallel strings of batteries, and that's going to cause all kinds of problems. Lastly, as the battery bank gets larger, often so does the loads, and so does the charging requirements. You put in a 2,000 amp hour battery bank, you need between a 200 and 400 amp charge source to get that flooded, or to get that lead acid battery bank to be fully charged with a reasonable amount of time. If you don't have it, say you're trying to charge that 2,000 amp hour battery bank with 100 amps of charging source, it's going to take 2 to 3 full solar days to get those batteries fully charged from just an 80% state of charge. That is going to kill the installation. Shoehorning product, sell the right solution to the job, not just what you have in stock. I understand that what you have in stock is eating up revenue and eating up time and eating up space. But if you're selling products that aren't right for the solution, you're going to have all kinds of problems. Okay, it's hard to explain, but if you're selling, an L16 in there when you should be selling an industrial size cell, you're going to have all kinds of problems, and that could eventually cause you legal problems as an installer. Not understanding C rates. Okay, in the solar business in North America, we generally size and design for the C20 rate. That means that if you discharge at the C20 rate in 10 hours, the battery bank is going to be 50% capacity. In 20 hours, that battery bank is going to be 100% dead. Okay. In Europe, they size the C10 rate because they typically have 10 hours of backup time. In telecom, you size the C100 rate. And so because most telecom systems are on a hill somewhere where it can take, between 12 hours and 5 days to get to the site. And so you typically size it at a lower C rate so you have a longer level of discharge so you have time to get up there before the system shuts down. So just an example, if you had a 445 amp hour battery bank and you've designed it for the C20 rate, that means that C20 rate, the customer is not going to pull more than 20 amps DC off that battery for a 10-hour period. 20 amps DC at 240 volts is 2.4, roughly 2.4 kilowatts, 2,400 watts. Let me make sure. Yeah, I'm sorry, that's 4,800 watts. So if the customer is drawing 20 amps AC, which is 4,800 watts, that's going to last about 10 hours of time before they go below 50% capacity. What if that customer runs an 8,000 watt load for 3 hours a day? That's going to decrease the overall capacity of the battery bank, making the battery bank smaller, which is going to make your system design, it's going to throw out that balance and make the system out of whack, and that'll cause you problems. Make sure you understand the product that you sell. I can't tell you how many phone calls that tech support departments around the world get. I get calls all the time. How do I set up my Outback controller? How do I set up my Magnum inverter? How do I set up my Schneider inverter? How do I set up my Victron inverter? How do I set up my midnight charge controller? I get calls all the time from electricians, installers, and homeowners that just don't understand the products that they've got. Read the documentation of the products that you're installing. Properly program all equipment of the system, because if you program a charge controller incorrectly, it's not going to charge the batteries correctly ever, and that's going to cause a failure regardless of the battery. If it's a lithium or if it's a gel or an AGM or a flooded lead acid, make sure you get it programmed correctly. Make sure you understand how that inverter works. If you don't, it's going to come back and bite you. Insufficient solar or other renewable sources installed. Most customers are living off grid because they don't want to hear a generator running 18 to 24 hours a day. Also, when you're running a generator, you're burning fuel at roughly, depending on the generator, it can be, $5 to $25 an hour just to run the generator, depending on how big the generator is and how big the system is. There is absolutely no reason with solar, the cost of solar being between 50 cents and $1.20 a watt, to not install an excessive or plenty amount of solar to get the system charged. It's free energy. Once you buy it, it's done. All you got to do is wash it off every once in a while squeegee the panels off, and you're good to go. Consider load use by time of day. You need to understand if your customer is going to run a lot of big loads midday, like air conditioning and stuff like that, you have to upsize the array to handle that. If you don't, your batteries are going to struggle to see a full 100% charge. That's going to cause problems. Size the solar production for the worst case scenario, i.e. solar production is different throughout the year. And so if you size the system for the solar production during the summer, come winter, that battery bank is going to struggle to get a fully 100% charge. And so that's going to cause you problems. Not understanding the pluses and minuses of different battery chemistries. Calcium batteries, like AGM batteries in gel, they're generally calcium-based batteries. They are meant for float application services, so they're perfect for a backup application. Okay. Lead antimony batteries are generally flooded batteries. Flooded batteries like the cycle, so they're good for a cyclical application, so a full off-grid system, stuff like that. Lithium batteries work great in both applications, but lithium batteries have temperature requirements. A lithium battery at 32 degrees Fahrenheit or 0 degrees Celsius will stop operating especially under charge. A lot of them will go down to negative 20 degrees C, which is about 10 degrees, negative 20 degrees Celsius, which is about 10 degrees Fahrenheit, if I remember correctly. And so, but once you get below that, they, especially under charge, they just shut off. They don't allow you to do it. It's like if you leave your cell phone sitting on the dashboard, when it gets too hot, it's going to shut off and not allow charging. So you need to understand the different chemistries that you're dealing with, the batteries. Another problem that a lot of guys make, a lot of installers and designers make, is trying to get too accurate on the system sizing. Don't spin your wheels sitting down and designing a system. One, the margins aren't that good, last time I checked. Two, it's better to miss high than miss low, to over design the system than it is to under design the system. That way the customer is taken care of and you get good feedback from your clients. You don't want to spin your wheels trying to over design a system. It's just going to drive you crazy. Not taking into account both warm and cold temperatures. Warm temperatures of just 35 degrees Celsius, which is about 140 degrees Fahrenheit, will reduce battery cycle life by 50%. Okay. Cold temperatures reduce capacity. So negative 9 degrees Celsius, which is about 23 degrees, 24 degrees Fahrenheit, will reduce system capacity by 63%. That means if you put in a 1,000 amp hour battery and you're trying to use 1,000 amps, you've only got about 470 amps of that battery bank, especially if those batteries are cold. Okay, so take that into account when you're designing, installing, and making sure you understand it. When I used to do a lot of flooded installations in the Mojave Desert, we would vault the batteries because just at 3 feet below ground, those batteries would operate at about would operate at a maximum temperature of about 85 degrees Fahrenheit, and those batteries would last a lot longer than if you just set them on the floor in a garage. And then lastly, not understanding the difference between a 12-volt battery bank and a 48-volt battery bank. So what we have here is we have 3 different battery banks. We have a 12-volt at 3,000 amp hours. We have a 24-volt at 1,500 amp hours and a 48-volt at 750 amp hours. What's the difference in the system? It's voltage, right? Well, the difference is nothing. Every one of these systems is the exact same capacity of battery bank. But to make a 3,000 amp hour battery bank at 12 volts, I need a whole lot of parallel strings. I can do the same exact battery bank at 48 volts at 750 amp hours with one series string of batteries or even 2 parallel strings of batteries. Okay, so the lower cell voltage you go, the higher the amp hour capacity, the better you're good. The other thing to consider is nowadays, most systems are 48 volt systems. And the reason for that is that when you're running a 48 volt system, your battery cabling is much smaller, much less expensive. You have less cells to check, less problems in general. All right, so sizing calculations. And so we're going to talk about the most common calculations. This is a Ohm's law pie chart. And so these are the most common calculations that you're going to make. To figure out watts, it's watts equals volts times current. So 100 volt or 48 volts times 1 amp is 48 watts. It's pretty simple. Volts equals power times current. So amperage, or the amperage times the wattage. So if it's 120 watts multiplied by 3 amps, that's 360. That's 300 or 120. Yeah. So volts equals power times current. All right. A little bit of a disclaimer. There's 100 ways to skin a cat. There's 100 ways to design a solar system. No way is specifically perfect. And so one of the things that you need to figure out as a solar designer is you need to figure out what way works best for you. I still use spreadsheets. Most of the time when I have a client call me up, they call me up and they say, Steve, I need a system that generates, that has 1 day of autonomy of 40 kilowatt hours a day. What I'll do is I'll take that 40 kilowatt hours, I'll multiply that by about a 20% loss factor. That becomes 48 kilowatt hours. 48 kilowatt hours divided by the depth of discharge. So let's say it's 50%. That now becomes 96 kilowatt hours. Divide that by 48 volts. That gives me a 2,000 amp hour battery bank. So in 45 seconds, 60 seconds, I know they need a 2,000 amp hour battery bank. I know the 2,000 amp hour battery bank is going to be roughly, $22,000 to $25,000. The inverters for that, you're looking at $10,000, $12,000. And then the solar panels to charge that, they need about 12 to 15 kilowatt of solar panels. So in general, you're looking ballpark probably $55,000 to $70,000. That's 2 minutes. And so if I'm talking to a client and he's saying he wants to put in the system, and I just quoted him $55,000 to $75,000, depending on the bells and whistles. If he's like, oh yeah, that sounds good, that's great. You probably sold the system. If the line goes dead or real quiet, then you probably haven't sold a system, or you start getting contradicting information. You probably haven't sold a system. So remember, with the internet now, everybody's a solar designer, everybody's an engineer. So you're not going to get away from the folks who try to fight with you about it. Back to the power consumption I showed you a little bit earlier, just a little bit of power consumption earlier. Again, the lighting is probably a little bit excessive, but that's fine. But we'll go ahead and take these examples. So calculating battery bank sizing for amp hours, I take that 15,750 kilowatt hours, so 15,750 divided by nominal battery bank voltage. That gives me 328 amps of current. 328 amps divided by 0.5 for a 50% depth of discharge. That equals 656 amp hours. And then I add 15% for a loss factor. That gives me a total of 754.4 amp hours. So for 1 day of autonomy, I need a 754 amp hour battery bank. Now, I don't do it this way anymore. And the reason I don't is, one, because watt hours are easy to discuss with the customer, and I'll explain that in a second. Two, if the customer comes back and says, oh no, I want a 24 volt battery bank, okay, you have to go back and do the calculations again. A lot of guys make the mistake where they don't do the calculations again and realize that now they need a 1,500 amp hour battery bank. They don't double that number, and now they just go ahead and put that same battery bank capacity in at 24 volts, and they lose wattage. And so that becomes a real problem. So this is 50%. This is based on 50% depth of discharge. So 15,750, add 15% loads, or losses. That's 18 kilowatt hours of usable energy. That becomes 36 kilowatt hours of total storage for this is again talking lead. We'll get into lithium in a second. So for 1 day of autonomy, we need 36.224. If I go back, 754.66, 754.4. Basically, we have a rounding error, okay? A little bit of rounding, which is no big deal. We basically have the same system. We're just doing the voltage calculation last. We're looking at watt hours first. And the reason for that is that now all you're going to do is if someone says, oh yeah, now I need that at 24 volts, that's 1500 amp hours. 12 volts is 3000 amp hours. And when they say you want 12 volts, run, because that's just going to turn around and bite you. The other thing is that we know we have 18 kilowatt hours of available storage. So they can run a 1K load for 18 hours. Oops. Okay. Or they can run a 500 watt load for 36 hours. Or they can run a 2000 watt load at roughly 7 to 8 hours. You just have to look at the C rates again to figure out specifically how long what you're going to be dealing with there. Okay. I do mine systems at a 25% depth of discharge. And the reason for that is that gives them 2 days of autonomy. Okay. That gives them 2 days of autonomy. Also, if they're only cycling 25% a daily, you can better guarantee that they're going to stay within that 25%. You're not depending on the inverters to do that. But the other reason is that you're ensuring that client doesn't take it down below 25% every single day. And so that increases the average cycle life of the battery bank. It makes the battery bank more expensive, but the system does last longer. And so for that same system, we would need basically a 1575 amp hour battery bank capacity, and their cycle life, if they use, say, the Series 5000 batteries, would be in the 6,000 plus cycle range. So that battery bank, if they cycled it every day, 365 days a year, 6,000 divided by 365 is over 16 years worth of life. So it would work. It would be just fine. Next, we have lithium, and so sizing watt hours for lithium batteries. I do the same thing for losses. So 15,750, I add 20% for losses. No system is perfect. Matter of fact, in every solar system, if you go through and you calculate all the possible losses of that solar system, you're actually closer to about 30% losses. So 20% is a good number to use. So that gives me 18,900 watt hours. On the lithiums, I typically size my lithiums at an 80% depth of discharge, not 100% depth of discharge. If you go to 100% depth of discharge, what will happen is you can see you'll see the cycle lives of the lithium batteries will drop. A lot of manufacturers won't tell you that, but the cycle lives, when they do that 100% depth of discharge cycling, it will affect the cycle life, especially if the manufacturer hasn't padded their numbers. A lot of manufacturers do pad their numbers, but we're starting to see a lot of manufacturers not pad those numbers because those batteries are so expensive at that because they've padded the size that you need to take that in account. So to make that, I'm looking at a 23.6 kilowatt hour battery bank. So that's equal to a 192 amp hour battery bank. Okay. And so, and so that would be like, for example, if you were using for example, our 6.6 kilowatt hour battery bank, that would be 4 of the 6.6 kilowatt hour battery banks or batteries in parallel. Okay. So in this case, like for example, let's go back to this one. If we needed a 1575 amp hour battery, I need at least 10 to 20, if this is lead, 10 to 20% of that battery capacity in charge current. We typically shoot for 15%. Okay. So I'm looking at about 200 amps current. So to charge that 1500 amp hour battery bank, I'm looking at ballpark around 12 to 16 kilowatts, 12 to 16 kW of solar to keep that battery bank fully 100% charged for a full off-grid system. If it's a cottage, you can probably get away with about 6 to 8 kilowatts. That's if it's a temperate environment. If you're in a really, really cold environment, I would bump that up to about 10 to 14 kilowatts. Okay. And the reason for that is the colder environments, you want to keep the batteries at a higher state of charge so they don't freeze. Now on a lithium battery bank, again, if this is lithium, I'm only looking about 5 to 10% actually about 5 to 15% of this number to keep that battery charged, because the lithium is acting much more efficient when there's charging. So one of the things that you want to be careful of is battery manufacturers, and this is coming from a battery manufacturer. Especially in the last 10 years, we have seen a lot of battery manufacturers promise a whole lot of stuff about the newer technologies that is just outright false. You are not going to get 10,000 cycles out of a lithium battery bank doing 100% depth of discharge cycling unless the manufacturer has oversized that battery bank by approximately 80 to 100%. Okay, so if they're advertising it as a 6 kilowatt hour bank, it's probably closer to a 10 to 15 kilowatt hour bank if you can get that kind of cycle life out of it. Lithium ferrophosphate is one of the safest chemistries out there. It'll still thermally run away at 70 degrees Celsius, which is about 140 degrees, 150 degrees Fahrenheit. Lithium iron or lithium iron cobalt, you can see thermal runaway temperatures in the range of 200 to 400 degrees Celsius. So you want to be careful with it. So this slide is to point out to you that when you start talking about batteries, a lot of people will talk about batteries, like for example, we see it every week. We see a new article. Some guys invented a hemp battery. Some guys invented a zinc battery. Some guys invented a carbon battery that has revolutionized the world, but it can't be manufactured. So you have to be careful. This quote is from Thomas Edison in 1883. So for roughly 140 years, we've been doing the same thing, except in the last 15, 20 years, we have seen a pretty substantial growth in the battery industry in general. So just a summary, off-grid home, 1 day of autonomy, system needs 36.2 kilowatt hours of storage or 750 amp hours using 15% losses. For exercise sake, we would install 16 S6L16HCs, which are 2 parallel strings of L16 batteries. What size solar? Again, for this size solar on a 754 amp hour battery bank, I want between 75 to 150 amps of charge current. To get 75 to 150 amps of charge current, I'm going to need between a 6 and 8 kilowatt solar array. Okay. I apologize for my chicken scratch. So if we were to do the same battery bank on lithium, okay, let me go to the next page. So just keep in mind, when the absorption stage starts, a flooded lead acid, AGM, or gel battery bank is ballpark between 80 and 85% state of charge. An off-grid array should be 10 to 20% of the battery bank capacity. The sweet spot's that 15%. For a grid-connected backup, it can be smaller, or even a cottage, it can be smaller, as low as 5%. But remember, if the customer goes out to that cottage and they spend more than 3 or 4 days there, they're going to have to run a generator to supplement because the array's not large enough to fully recharge the battery. Okay, so on a lithium-based battery, the absorption starts at about 95% state of charge. Okay, and so there's a huge difference in state of charge. So that because the lithium battery bank charges much more efficiently, and so a lithium battery bank, you're going to see a little bit smaller array, and that little bit smaller array is going to be much more efficient. So the sweet spot of charging a lithium bank is about 8 to 10% of the C20 rate. So if it's a 600 amp hour battery bank, I'm looking 40 to 60 amps of charging current. You just got to keep track of what lithium battery you're putting in. The one thing to be cautious of is you don't want to be this guy. This is a picture taken from an actual solar system. You don't want to be this guy. Trust me, this is a very large solar installation company. There's actually a sign right down in this area that says proudly installed by. I'm not going to tell you. And so I edited out the sign so to keep things away. This is what happens when you start leasing systems, and if you don't care about the performance of the system, all you care about is getting the rebates back. Doesn't make a whole lot of sense. If you're going to install a system and you're going to mow these aisleways, Why not just weed eat the areas underneath? You've got all kinds of weeds growing out of the solar array. You're seeing all kinds of imperfections, all kinds of problems. This next solar array, we've got four parallel strings of 3. This set of 3 aren't doing anything. They're actually dragging down the entire array because of the shading. Make sure that when you install this stuff that you account for these things. Panels need to be cleaned. And so this specific panel is not being cleaned very well. Matter of fact, it looks like the racking is actually holding up the roof. This is actually installed in Amboseli, Kenya. It's an elephant reserve down in southern Kenya on the border of Kenya and Tanzania. So this is also installed at the same park. This was actually kind of cool. You can see the railing on the side here. That railing is actually meant to fix this grating down here. So we have this grating down here, and that fits on top of there. And so what that was meant to do is it was meant to keep the baboons off the panels. The problem is that this grating is kind of like fencing, and they just welded a frame around it. And so once you put it over the top, it puts an entire shading on the PV array, and that's just going to cause all kinds of problems. Something not to do. You don't want to do that. You know, they had to cut this railing off and then start cleaning the panels. They actually elevated the panels up a little higher because you also have a shadow line across here from a radio tower. You can actually see the guy wires from the radio tower. And so that was causing a shadow as well, reducing the performance of the system. So you don't want to be those guys. Make sure you install the array clean, nice and neat, so you're getting decent production on your PV array. Because if you're not, it doesn't matter what battery technology you install, it's going to affect it. Well, I hope that helps. I want to thank everybody for listening. If you're watching this on YouTube, hey, do me a favor. If you didn't like the video, you can click on the dislike button, but the thumbs down button. But send me a message. Let me know what you didn't like about it. If you liked the video, great. If you have any other questions or other ideas, feel free to send me an email. My name is Steve, and my email address is steve@surratt.com. Thank you. You have a good day.